Let's do a few more examples and then we'll call it quits in this section. So what happens if we have f of x is 1 minus x to the 2/3 power. So f prime of x is going to be minus 2 over 3 times 1 minus x to the 1/3 power. So this is never equal to 0. So we don't have any critical points because f prime of x is equal to 0. This is undefined when the denominator is equal to 0. Undefined when 1 minus x is equal to 0, which is x is equal to 1. So that's our only critical point. So we can draw a chart here. X is equal to 1, f prime of x. If we test, let's say, and we test 0 here, f prime of 0 is going to be minus 2/3. That's negative. If we test something like 2 here, f prime of 2 is going to equal positive 2/3 plus, 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 plus. And so we see, what do we have here? Change from minus to plus. This is a local min. What does the function look like in this case? Something like this. That should just kind of like that. So this is an example just to show that we can still do the analysis when we have this kind of cusp going on here, place where the derivative is undefined. That can still be a critical point. We can do the same analysis. And one last example. If we look at f of x is equal to x minus sine of x. So f prime of x is equal to 1 minus cosine x. So this is always going to be defined. So we set it equal to 0. So when is cosine x equal to 1? That happens exactly when x is 2n pi, where n is an integer. So it happens at 0 and 2 pi and 4 pi and 6 pi and 8 pi, and also at negative 2 pi and negative 4 pi and negative 6 pi. However, f prime of x is never negative. It's either 0 at our critical points, or it's positive at everything that's not the critical points. And so what does the graph of the function look like? So it goes through the critical point, increases, goes through a critical point, then it increases. It's kind of like this. So maybe a little bit less extreme than what I'm drawing here, but this is the kind of thing that we're going, that it's increasing, hits a critical point, increasing, hits a critical point, increasing, hits a critical point. It's increasing everywhere other than the critical points. So that's just a couple examples to finish off the section.